Alright, here I'm going to show you a couple examples of what it means to solve a right triangle. So, first and foremost, you need to remember your trig functions. Remember, we have 6. We've got sine of theta, we've got the cosine, we've got tangent, and then we have their minor partners. So those would be the cosecant of theta, the secant, and the cotangent. Okay. So with that, we also have to remember we've got Pythagorean's theorem and the rule here, which is that all triangles have to sum to 180 degrees. So when you're solving a right triangle, all you're simply doing is trying to find the missing parts. So notice here I have an S, a T. Neither one of these have lengths. I've got a degree here. I don't have a degree here. But I have to go ahead and assume that I know this is going to be the 90. Now the reason I'm assuming that is because my directions tell me that this is a right triangle. If your directions don't say that this is a right triangle, then trying to make this assumption is a very tricky assumption to make. Okay, so just be careful and read your directions very precisely. So the first thing I would do is the easy part, which is find my missing angle. And in order to do that, just simply says that I have to remember that the sum of my angles equals 90 degrees. So if I already have 90 degrees sitting here in one part, that means the sum of these other two has to be 90. So when I'm looking for angle T, I simply need to do 90 minus 26.7, and that's going to give me my missing angle. So in this case, we should get 63.3 degrees. Now, that also means, even though I've put the box here, because we're trying to solve it, you still have to list it, that angle S was 90 degrees. Okay, solving your triangle. Now I need to find my side lengths here. So what I have to remember is I need to use a reference. My advice would be use the angle that's been given to you as your reference angle. And so here I want to find, say, T. Well, based on the angle present, T has to be opposite, or adjacent over hypotenuse. But in this case, that doesn't work. The only thing I have is opposite. So one of the things that I can use is I can use the fact that the tangent equals opposite over adjacent. So I'm going to go ahead and do that. I'm going to use that the tangent of my angle is going to give me that opposite over adjacent factor. So what does that look like? Well, this is saying that the tangent of 26.7 is equal to opposite 0.17 over my unknown T. I need to solve for T, so I'm going to multiply both sides by T and then divide both sides by my tangent. So my T here is going to be the 0.17 divided by the tangent of 26.7. All you have to do is plug that into your calculator. So we're going to pull that out right here. And so again, we're going to do 0.17 and we're going to divide it by the tangent of 26.7, and that is going to give you that length. Okay, so in this case, since my first side length here only rounds to the hundredths, all of them should match. So in this case, I would take my decimal of 0.338, I would round that up, and I would say that T is equal to 0.34. Now the other one that I have to find here is my S, and there's two ways that we could do that. First, you could find it by using Pythagorean's theorem. We know two sides, and so we could use it. However, if you want to be really exact and assume that we have made a mistake calculating T, then we would use trig functions in order to find s. So in this case, to find s, we have opposite, and s would be your hypotenuse. So here we would use the sine of theta, which gives you opposite over hypotenuse. So here this would be the sine of 26.7 is equal to 0.17 over my s. Again, we're going to do the same thing. S is going to equal 0.17 divided by the sine of your angle, 26.7. And in doing so, we should come out with our s value. So just like before, we're going to use our calculator here. So we've got 0.17 divided by the sine of 26.7. And so again, here we're going to round to 2 decimal places. So 0.378 is going to become that s is 0.38. So I have now labeled everything that was missing out of my triangle. So let's just refresh real quick. I was given an angle and I was given a side length. I had 2 angles missing and 2 side lengths missing. That means I needed 4 answers. I found angle T, angle S, side length T, and side length S. There's my 4 answers, so I've solved my triangle. Now what happens if we're given the problem like this one, but we're not given the triangle? Well, you guessed it, you would then want to draw it. So in this case, I'd go ahead and draw myself a triangle. So we're going to draw ourselves a right triangle. So I'm going to input my right triangle box, and then I need to label it. So we're told that side lengths are A and B, which means we know we have angle A, we have angle B, we have angle C. This means we have side length A, side length B, and side length C. Furthermore, we know that side length A is going to be 12.5, and we know B is going to be 18.3. Okay. Now with this one, I don't have a given angle to start with. I'm just starting with my 2 side lengths. Okay. So the first thing that I would do is I would use the fact that I could use Pythagorean's theorem in order to find my C value. So here I would start by saying that a squared plus b squared is equal to c squared. Plug in your a and b, so I get 12.5 squared plus 18.3 squared has to give me c squared. Again, you would use your calculator. Okay, so as a refresher for anybody lost, you'd open a parentheses, 12.5, close your parentheses and hit your square button. We're going to add that, open parentheses, to 18.3, close it, and again hit the square button. So that right there is your c squared value. So you're going to take the square root of your answer and you're going to hit enter. And so here we're going to end up with c being 22.2. Now I rounded up to my first place here purely because all of my other digits were just like that. So you always want to make your answers look the same. So now I've got my first length. Well, beyond that, I now have to use the idea of my trig functions in order to find, say, a and b. So the first thing is I could go ahead and work with my theta being down here at angle A. So what I have when I look at my theta value here is I have opposite over adjacent. So I am going to say that the tangent of theta is going to be opposite 12.5 over the adjacent 18.3. Well, all we need to do is solve for theta. So in this case, my theta value is going to be tangent to the negative first of 12.5 over 18.3. So if you look at your calculator, we have that. Above my tangent button here is this tangent to the negative first. And so I want to go ahead and use that. So I'm going to go second tangent, which inputs tangent to the negative first, and then I'm going to input my values, 12.5 divided by 18.3. Close that and hit enter, and we have 34.3 would be our degree. So here we would say that we have angle A is going to be 34.3 degrees. Now the other one that we have to find is angle B. So now let's move my theta up here to B, and if we look again, we have opposite over adjacent. So here we once again are going to use the tangent of that theta, and in this case we're going to have 18.3 over 12.5. Well, this is the same as the problem we just did. Solve for theta, and we get tangent to the negative first of 18.3 over 12.5. So again, we're going to plug this into our calculator using the same method we just did. So we're going to go second tangent, and then we've got 18.3 divided by 12.5, close it, and hit enter. So here we're going to end up with 57 or 55.7. So here we've got that angle B is going to be 55.7 degrees. Now the last thing that we know is we know then that angle C was my 90 degrees. And so there that is, in a nutshell, everything that you would need to know in order to solve right triangles. So if you have any questions or feel the need to see more examples, please let me know. Otherwise, I hope you enjoyed. Remember to be creative, and I'll see you next time.